Imagine it is the year 2050. You wake up, but your phone screen is black. It has been black for 20 years. There is no internet to check the news, no GPS to guide your car. The self-driving vehicles you were promised, they are rusting in scrapyards, useless metal shells. The global economy, once a lightning-fast digital network, has crawled back to the speed of paper and cash. You look up at the night sky. You don't see the twinkling lights of Starlink satellites anymore. You don't see the bright beacon of the International Space Station. You don't see the ships leaving for Mars. Instead, you see a cage, a shimmering, deadly haze of metal and dust that wraps around our planet like a shroud. It wasn't a nuclear war. It wasn't a plague. It was a mistake we made back in the 2000s. A mistake born of our own success, our greed, and our arrogance. We launched thousands of satellites. We celebrated every rocket launch. We cheered as companies raced to fill the sky with metal. We thought the sky was infinite. We thought we could just throw things up there and forget about them. We were wrong, and that was the fatal error. We forgot that what goes up must stay up, unless you bring it down. And because we didn't clean up our mess, we triggered the Kessler Syndrome. Right now, in 2024, we are sitting on a ticking time bomb. There are over 100 million pieces of debris orbiting Earth. Most are smaller than a marble. You probably think, so what? It's just space junk. That is the dangerous mindset that doomed us in this simulation. And here is the nightmare. Those new pieces don't stop. They become bullets. They fly off and hit other satellites, which create more pieces, which hit more satellites. It is a chain reaction, an unstoppable domino effect of destruction. What if that first domino falls tomorrow? Imagine a world where one collision triggers a cascade that wipes out our GPS system. Suddenly, airplanes are flying blind, cargo ships are lost at sea. Emergency services can't find you. We become blind to approaching hurricanes and tornadoes. Millions die because we lost our eyes in the sky. And the ultimate price, the cage. The debris cloud becomes so thick, so dense with high-speed bullets that leaving Earth becomes suicide. Any rocket we launch would be torn apart before it reached orbit. We would be locked out of the universe. No Mars colonies, no asteroid mining, no second chance. Humanity's destiny among the stars, canceled. In this video, we are going to deconstruct the Kessler Syndrome. We will explain why a single screw moving at orbital velocity is deadlier than a grenade. But most importantly, we will show you how to survive this crisis. We will introduce you to the space janitors, the scientists and engineers who are building giant nets, harpoons, and lasers to clean up the mess before it's too late. We have one chance to get this right. We are the last generation that can stop the sky from falling. So we have this terrifying vision of the future, but to stop it, we first have to understand the weapon. And the weapon is a fleck of paint, a loose screw, a dead satellite. Let's talk about orbital velocity. To keep a satellite in orbit, to stop it from falling back down to Earth, it has to move fast, incredibly fast, specifically about 17,500 miles per hour. Let's put that number into perspective. That is 10 times faster than a bullet fired from a high-powered rifle. It's fast enough to travel from New York to London in about 15 minutes. This isn't just theory. We have seen the scars. The windows of the space shuttle were often chipped by flakes of paint floating in orbit. In 2016, a tiny piece of debris, maybe a millimeter wide, punched a hole in the solar panel of the Sentinel-1A satellite. It left a crater 40 centimeters wide. A millimeter created a crater. Now scale that up. What happens when a dead satellite, the size of a school bus weighing several tons, is hit by a piece of debris the size of a smartphone? It doesn't just punch a hole. The energy release is so massive that the satellite doesn't just break. It vaporizes. It disintegrates into a cloud of thousands of new fragments. And remember, in space, there is no air resistance to slow things down. Those new fragments don't stop. They keep flying at 17,500 miles per hour, spreading out into new orbits, becoming a shotgun blast of new bullets. And here is the problem. Space is getting crowded. In the last few years, companies like SpaceX have launched thousands of Starlink satellites. The number of active satellites has doubled and then tripled. Every launch adds risk. Every dead satellite left in orbit is a ticking time bomb waiting for a trigger. And we have already had close calls. In 2009, two massive satellites, Iridium 33 and Cosmos 2251, collided over Siberia. It was a violent hypervelocity crash that created over 2,000 pieces of trackable debris and thousands more too small to see. And that debris is still up there today, but that collision was just a single event, a warning shot. What happens when the density of debris gets so high that one collision triggers 2, which triggers 4, which triggers 16? What happens when the chain reaction becomes self-sustaining and unstoppable? This is the nightmare scenario, the Kessler Syndrome, and in our next chapter, we will run the simulation. The concept was first proposed in 1978 by NASA scientist Donald Kessler. He realized a terrifying truth about putting things in orbit. Space is big, yes, but the useful orbits, the lanes where we put our communication and spy satellites, are actually quite narrow, and they are getting crowded. On a highway, a crash stops traffic. The cars pile up, but they stop moving. In space, a crash accelerates the danger. Let's run the simulation. It starts with 2 dead satellites, maybe an old Russian spy satellite and a defunct weather satellite. They cross paths. Boom! They don't just fall to Earth, they shatter into a cloud of shrapnel bolts, solar panels, batteries, casing. This cloud doesn't stay put. It continues to orbit, spreading out into a deadly ring of debris around the planet. Now, instead of 2 satellites, you have 10,000 uncontrolled bullets flying through the busiest traffic lane in space. It's statistically inevitable that one of these new bullets will cross the path of another satellite. Maybe it hits a Starlink satellite providing internet to Europe. Smash. That satellite explodes, adding another 5,000 pieces of debris to the cloud. This is the Kessler Syndrome in full effect. The density of debris becomes so high that collisions start to happen automatically. We don't need to launch anything else. The trash is now colliding with the trash, grinding itself down into smaller and smaller pieces, but creating more and more projectiles. The debris cloud grows thicker. It spreads from one altitude to another. It becomes a self-sustaining chain reaction. At this point, any satellite remaining in orbit is doomed. It's like trying to walk through a sandstorm without getting hit by sand. The International Space Station, it would be riddled with holes, forced to evacuate or be destroyed. The Hubble telescope, blinded and battered. Our eyes in the sky would go dark one by one. This isn't just about losing some expensive hardware. This is about losing access to space entirely. If the debris field becomes too dense, we can't launch new rockets. A rocket trying to pass through that cloud would be like a soldier trying to run across a battlefield under heavy machine gun fire. It would be torn to shreds before it could reach safe orbit. So the trap is set. The chain reaction has begun. The prison walls are going up. But what does this actually mean for you down here on the ground? You might think, I don't plan on going to space, so who cares? You should care. Because the death of satellites doesn't just mean no more Mars missions. It means the collapse of the modern world as you know it. It means a return to the 1970s, but with a population of 8 billion people who have forgotten how to live without the digital umbilical cord. In our next chapter, we will turn off the satellites and watch the lights go out on Earth. Let's walk through the domino effect of a post-Kessler world. Domino 1, the death of GPS. This is the first and most painful blow. You lose Google Maps on your phone. Annoying but manageable right-wrong. GPS is not just a map. It is the world's timekeeper. The banking system, the stock market, the power grid, they all rely on the ultra-precise atomic clocks on GPS satellites to synchronize their transactions. Without that signal, ATMs fail. Credit cards stop working. Financial trading halts. The global economy freezes. Airplanes are grounded because modern air traffic control relies on GPS. Cargo ships carrying food and fuel are lost at sea or forced to navigate by the stars, slowing global trade to a crawl. The supply chain snaps. Domino 2. The blindness. We lose our weather satellites. We go back to the days of looking out the window to predict the weather. Hurricanes could strike coastlines with little warning. Farmers lose the data they need to plant and harvest efficiently. In a world of climate change, losing our ability to monitor the planet is a death sentence for millions. Domino. 3. The silence. Satellite internet, satellite phones, satellite TV, all gone. Remote communities are cut off. News from the other side of the world takes days to arrive, not seconds. The global village fractures back into isolated islands of information. It is a terrifying vision. A future stolen by our own negligence. If you value this kind of deep dive analysis, if you want to be part of a community that looks these dangers in the eye, then take a moment to hit that subscribe button. Join us. We are building a library of survival knowledge for the modern world. Because here is the twist. The Kessler Syndrome is a mathematical probability, but it is not yet a certainty. The cage door is closing, but it hasn't locked yet. Humanity has a history of creating messes, but we also have a history of inventing incredible, almost magical solutions to clean them up. We are not just going to sit here and watch the sky fall. We are going to fight back. Can we save the future? The answer lies in the next few minutes. We have stared into the abyss. We have seen the prison. We have felt the weight of a future without stars. But surrender is not in our nature. The Kessler Syndrome is a problem created by technology, and it will be solved by technology. Right now in labs and clean rooms around the world, a new generation of engineers is preparing for the ultimate cleanup job. They are the space janitors. Let's meet the arsenal that could save our sky. Solution 1. The Space Harpoon. It sounds primitive like something from Moby Dick, but it is brilliantly effective. Imagine a chaser satellite equipped with a high-tech harpoon gun. It tracks a dead, tumbling satellite, a dangerous piece of space junk the size of a car. Solution 2. The cosmic net. What if the debris is spinning too fast for a harpoon, or what if it's a cloud of smaller fragments? You use a net. Inspired by fishing trawlers, this satellite launches a weighted net that wraps around the debris, tangling it up. Once captured, the package is dragged down to burn up. It is a simple, elegant way to catch the uncatchable. Solution 3. The laser broom. This is where it gets truly futuristic. We are not talking about blowing up satellites like the Death Star. That would just create more debris. We are talking about using ground-based lasers to gently nudge debris. The laser heats up one side of the debris. As the material vaporizes, it creates a tiny jet of gas that acts like a thruster, pushing the debris just enough to slow it down. Once it slows down, gravity takes over and pulls it into the atmosphere. It is a way to clean up the smallest, deadliest bullets without ever launching a rocket. But these machines are just the beginning. The real solution is not just cleaning up the past, it is changing the future. The new rules of the road. We are entering a new era of sustainable space. New laws are being written. Satellites are being designed with de-orbit plans, graveyards in the ocean where they can crash safely. Reusable rockets are reducing the junk we leave behind. We are learning to treat space not as a dumping ground, but as a finite, precious ecosystem. The Kessler Syndrome teaches us a profound lesson about responsibility. It reminds us that progress without foresight is a trap. It forces us to realize that our actions, even in the vastness of space, have consequences that can echo for centuries. But it also proves something incredible about us. We are the only species that can create a planetary scale problem, and we are the only species smart enough to fix it. Our curiosity got us into this mess. Our ingenuity will get us out. The sky is not falling. Not yet. The door is still open. And as long as we keep looking up, keep innovating, and keep asking why, we have a fighting chance to keep it that way. Thank you for joining us on this journey. Stay curious, stay safe, and keep watching the stars.